Okay, children. So we are going to discuss about the critical angle and total internal reflection definitions, consequences, factors, numericals, formulas, everything we'll discuss. First, what is a critical angle? Children, I told you first you should know what is a refraction. Do you remember what is refraction, girls? Refraction is bending of light when it passes from one medium to other medium. Bending of light when it passes from one medium to other medium. And I told you that suppose this is air, this is water. Okay, this is normal. Rarer to denser. What happens? It bends towards the normal. Rarer to denser, it moves towards the normal. And denser to rarer, it moves away from the normal. Denser to rarer, it moves away from the normal. Denser to rarer, it moves away from the normal. So now I am telling about critical angle. All of you see here, children. Try to understand. Okay, try to understand, children. So imagine this is water. Water means anyway denser medium. Compared to air, water is denser medium. Okay, so children, this is normal. Denser to rarer. Varsha, what happens? Denser to rarer, light moves. Varsha, denser to rarer, light moves away from the normal. Okay, children. Varsha, are you there?
Yeah, sir.
Why you're not answering? I'm asking question three times. I asked.
Sir, it took me time to unmute, sir.
Okay. Denser to rarer, it moves away from the normal, children. Denser to rarer, it moves away from the normal. Suppose if I increase this angle of incidence a little bit, then it will take like this. Suppose if I still increase the angle of incidence at one particular angle of incidence, it goes through the medium like this, children. Okay, children, making 90 degrees with the normal. That is called critical angle. What is critical angle means? It is the angle of incidence in denser medium. What is critical angle? Children, what is critical angle means? Try to understand, children. Critical angle means angle of incidence in denser medium. Try to understand. Angle of incidence in denser medium. Children, this is critical angle. What is critical angle means? Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. For which angle of refraction in rarer medium is 90 degrees. That is called critical angle, children. Again, I am saying those who didn't understand, just see here. It will go like this. If you still increase, it will go like this. If you still increase, it grazes through the medium. That angle of incidence for which angle of refraction is 90 degrees. This angle of incidence for which angle of refraction is 90 degrees. This angle of incidence for which angle of refraction is 90 degrees is called critical angle. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees is called critical angle. Try to understand, children. Okay, angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees is called critical angle. So try to understand. I hope you are able to understand, children. Normally, children. So we know refractive index is equal to sine I by sine R. Sine I by sine R. We know from Snell's law. Okay, children. So normally this is angle of incidence. Okay, this is angle of incidence, this is angle of refraction normally, because this is formula for rarer to denser. This is formula for rarer to denser. But denser to rarer is going like this. Try to understand, children. Don't worry. Okay, I will say. See how I do like that only. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. We know mu. See, children. If it is coming air to water, it is sine I by sine R. Sine I by sine R. But light ray is coming from water to air. Water to air, then it is sine R by sine I. Sine R by sine I. Okay. So when light is entering from water to air, so sine R is how much, children? 90 degrees. Means sine 90. and sin I is our children sin C. So refractive index is equal to 1 by sin C. This is the formula for refractive index. And what are the conditions necessary for critical angle? What are the conditions necessary for critical angle? Compulsory condition. Condition means light ray should go from denser to rarer only. Rarer to denser is not possible. If it goes denser to rarer only, it goes away, 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 and at what particular angle it means 90 degrees. What is the condition for critical angle? Light ray should go from denser to rarer
Denser to
only.
rarer.
Compulsory denser to rarer. Rarer to denser, this is not possible, children, because it comes towards. Denser to rarer, it goes away. So this is the condition, first condition. Okay, and what are the factors on which critical angle depends? What are the factors on which critical angle depends, children? What are the factors? First factor. Okay, children, the first factor on which critical angle depends is number one, children. It depends upon color, and number two, it depends upon temperature. Okay, how it depends on color, sir? You will ask, children. Normally, how it depends upon color. See, children, refractive. See, for this slowly, I will say, try to understand, children. Slowly, I will say. Normally, when you draw prism, if light rays are going, all rays will go like this, children. Okay. So, violet is deviated most and red is deviated least. Children, try to understand. Children, violet is deviated most. Violet is deviated most means it has more refractive index. And red is deviated least means it has least refractive index. And we know refractive index is inversely proportional to critical angle. Because this has least refractive index, it has most critical angle. Red has more critical angle, and since violet has more refractive index, it has least critical angle. Why? Because refractive index is inversely proportional to critical angle. Try to understand. Violet is deviated more, so it has most refraction. Violet is deviated more, so it has most refraction and least speed also. And fast is red because it is fast, highest wavelength also, and this is least wavelength also. You should know and try to understand whichever is bending more, that has more refraction. Refraction is refractive index. Okay, children, and how it depends upon, so color is, so children, color, how it depends upon critical angle, children, color, how it depends upon critical angle, children, color, how it depends upon critical angle. Red has most critical angle. Critical angle. Why? Because it has least refraction. Okay, refraction and critical angle are inversely proportional. Okay, children, try to understand refraction and critical. Okay, next question. And dependence on temperature. On increasing the temperature, children, its refractive index decreases. Okay, refractive index is inversely proportional to temperature, children. How, sir, you may ask? Simply, I will say, children, very, very easy. See, children, on heating any object, it will become hot. On becoming hot, molecules move far. When molecule moves far, any object will become light. Any object becoming light means it is a rarer medium. So try to understand, if any object is becoming hot, it will have less refractive index. Again, those who did not understand, again I will say, if you are heating any object, it will become hot. Hot objects will, molecules will go far. When it goes far, it will become light. When it goes light, it will become rarer. So refractive index is inversely proportional to temperature, and refractive index is inversely proportional to critical angle. Therefore, critical angle is directly proportional to temperature. Simple, children. Okay, critical angle for a variable media increases. Thus, critical angle increases with increasing temperature. More temperature, more critical angle. More temperature, more critical angle. Because refractive index is inversely proportional to temperature, refractive index is inversely proportional to critical angle. So these both are directly proportional. Critical angle is directly proportional to temperature. More temperature, more critical angle. More temperature, more critical angle. Okay, children. So, what are the factors affecting color and temperature? Please remember. And what are the conditions? The light should go from denser to rarer medium. And what is the formula? Mu is equal to 1 by sin C. Okay, 2-3 small numericals we will do, children. 2-3 small numericals on critical angle. Then we'll go to total internal reflection. First question. Okay. First question. Small numerical. Okay. First question. Find refractive index of glass or medium, I will say, children. By means glass, water, all these are standards. Just I will say, find the refractive index of medium whose critical angle is 30 degrees. Who will tell? Girls, who will tell among you three? Girls, who will tell? Girls. Oh God. Refractive index is equal to 1 by sine C. Refractive index is equal to 1 by sine 30. Refractive index is equal to 1 by 2. Refractive index is equal to 2. This is first question. Those who did not understand, second question. Find refractive index of a medium whose critical angle is 45 degrees. Whose critical angle is 45 degrees. Okay, children, same question, children. So refractive index is equal to 1 by sine C, 1 by sine 45, 1 by root 2. So answer is root 2. Refractive index is root 2. Okay. So one more sum, children, for those who didn't understand. Refractive index, find refractive index if critical angle is 60 degrees. Find refractive index if critical angle is 60 degrees. So mu is equal to 1 by sine 60. Mu is equal to 1 by sine 60 is how much, children? Root 3 by 2.
3 by 2.
So 2 by root 3 is refractive index of that medium. Formula is same. Mu is equal to 1 by sine. See, that's it, children. So critical angle definition is angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. Angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degrees. Try to understand, children. Okay, be active in the class. Next question. Total internal reflection. What is total internal reflection? I hope everyone understood this, children. So, what is total internal reflection? Try to understand. So, children, please see here. This is water, this is air. Okay, I told you, denser to rarer, it moves away from the normal. If you increase further, it will go like this. If you increase further, at one particular angle, it grazes through the medium. I told that is critical angle. I told that is critical angle. I will increase further, more than critical angle. Then refracted ray comes back into the same medium. That is called total internal reflection. Okay, what is total internal reflection? Means if angle of incidence is more than critical angle. This is angle of incidence. If angle of incidence is more than critical angle, if angle of incidence is more than critical angle in denser medium, if angle of incidence is more than critical angle in denser medium, if angle of incidence is more than critical angle in denser medium, then refracted ray, this is different, comes back into same medium, comes back into same medium, comes back into same medium. Okay, it is called total internal reflection. It is called total internal reflection. If angle of incidence is more than critical angle, if angle of incidence is more than critical angle, if angle of incidence is more than critical angle, refracted ray comes back into same medium. This is called total internal reflection. What are the conditions required? First condition, light ray should go from denser to rarer. Light ray is compulsory denser to rarer only, it is possible, rarer to denser not possible. Number two condition, anyone? What is number two condition? Can anyone say what is the number two condition? Common sense, children. What is number two condition? What is number two condition? Anyone? Angle of incidence should be more than critical angle. Angle of incidence should be more than critical angle. Then only total internal reflection occurs. Okay. So some of the things which are under the total internal reflection in normally in the outer atmosphere, children. Number one, diamond. Diamonds, they don't shine in their natural state, but when they are cut in proper angles, they will shine. Why means the diamond cutters who are there, they will cut in such an angle that light ray goes at an angle more than critical angle. Light ray goes at an angle more than critical angle. The total internal reflection occurs, and forever it keeps on reflecting, and diamonds shine. And even children, optical fibers. which are used in internet connections and phone connections which are laid under the ground, they also work under this one only. Children, sometimes you see a crack in a glass. If you see a crack in a glass, sometimes it shines. Why does it shine? Because of total internal reflection. Okay, an empty test tube, if you put in a water beaker with its mouth outside, the water surface shines like a mirror. This is also because of this the empty test tube which you keep in the water. That is also total internal reflection. And mirage. Do you know what is meant by mirage? Mirage. If you are going in a hot sunny day on a highway when you are going on a hot sunny day, when you are seeing on the distant, you will see on the road there is some water. On the highway there is some water. If you are going in the car on a hot sunny day on the road, you will think there is a water. But if you go near, there is no water with the edge. This optical illusion is also mirage. It is called is also because of total internal reflection. Okay, children, this is total internal reflection. Now, total internal reflection and in some cases, how to do, I will show you, children. Okay, total internal reflection, in some cases, I will show you, children. So, this is this one, in some situations. So definition is very important. If angle of incidence is more than critical angle, if angle of incidence is more than critical angle, refracted ray comes back into same medium. If angle of incidence is more than critical angle, refracted ray comes back into same medium. If angle of incidence is more than critical angle, if angle of incidence is more than critical angle, refracted ray comes back into same medium. Okay. So in different prisms, how total internal reflection takes place. Suppose you are taking a isosceles right angle triangle. Isosceles right angle triangle, these both sides are equal. This is 45 degrees. This is 45 degrees. Okay. In this situation, suppose if a light ray is coming like this, if a light ray is coming like this, all of you see here, children. If this is 90, this is also 90. This is also 90. This is 45. This is 90. By angle some property, this is also 45 degrees. Okay. So, children, what happens at this point, draw one normal. Draw one normal. Okay. If this is 45 degrees, this is also 45 degrees. Okay, it will go like this, children, making this is also 45 degrees. Why it will go like that means this is incident ray, this is reflected ray. From laws of reflection, we know angle of incidence is equal to angle of reflection. If this is 45, this is also 45, it will go like this from down, children. Okay, anyone have any doubt? Shall I explain again or more it, children? If you want, I will explain again.
Can you explain it again?
Okay, second question, yeah. So, see in this case, what is happening is slowly I will say light ray is coming like this. Children, this is 90, this is 45. If this is 90, this is also 90, parallel rays. If this is 45, 90, this is also 45. Draw normal. Angle of incidence means incident ray and normally angle of incidence. This is also 45 because 45 and 90. It will reflect like this, making 45 degrees because angle of incidence is equal to angle of reflection from loss of reflection. I will explain one more, then you will understand, children. Suppose same this one, I will keep like this. This is 90, this is 45, this is 45. Suppose light ray comes and hit like this. Okay, if light ray comes and hits like this, all of you see, children, here. Slowly I will tell, slowly. So children, this is 90 degrees, this is 90 degrees, this is 45, this is also 45. Okay children, this is also 45. Draw normal. If you draw normal, children, another light ray should go with 45. If this is 45, children, this also will be 45. Okay, again you draw normal, children. If you draw normal, what happens means, see here, children, if this is 90, this will be 45, this will be 45. Okay, total will be 180. No. Slowly try to understand. If this is 45, this is also 45. And angle of incidence is equal to angle of reflection from loss of reflection. Then it goes like this because this is 45, this is also 45. Angle of incidence is equal to angle of reflection. If you hit like this, it will come like this. You should try to understand. Only I use angle sum property. That's it. Nothing more than that. One more question, children. Same 90, 45, 45. This is 90, this is 45, this is also 45, 90, 45, 45. Okay, so what is the question is, light rays are coming like this, children. How means it is coming like this, see here. Light rays are coming like this. Whenever light ray come like that, children, be careful, children. We have to draw normal as usual. Normal is compulsory, children. Normal is compulsory. When you draw normal, normal means 90 degrees. Normal means 90 degrees, children. Okay. Whenever it comes, this is rarer. This is denser. Okay. Rarer to denser. We know always light ray moves towards the normal. Means it moves towards the normal, and somewhat it comes like this, children. Okay. After coming here, see children, angle of incidence should be equal to angle of refraction. It will hit like this, children. Okay. And here at this position also draw one normal. Denser to rarer, it moves away from the normal. It will go like this. You have to understand, children. You have to understand these concepts. Okay. Denser to rarer to denser towards the normal. I take it. Denser to rarer. This is normal away from the normal. I take children. Away from the normal. Next. Okay. When 60 degrees, children, in equilateral prism, this is 60, this is 60, this is 60. Equilateral prism is there, children. If light ray is coming like this, try to understand, like this. Slowly, I will say, try to understand, children, because telling again becomes difficult. Children, this is coming at 90 degrees, means here also 90 degrees. This is 90, this is 60. Can anyone tell me how much is this angle? Please help me. This is 90, this is 60. Can anyone tell this is how much angle? Huh? Yes, girls, how much?
30.
30, very good. 30. Someone is telling 30. Draw normal here. If this is 30, this will be how much, anyone?
30.
60. Because
Sorry.
normal means 90,
Yeah.
Amma. Normal means
Yeah,
90. Okay. And we know angle of incidence is equal to angle of reflection. One more light ray will go like this. This is also 60. If this is 60, children, if this is 60, this will be how much?
30.
30. If this is 30, this is 60. This will be how much?
90.
90. Yes, this is going like this. Simple. That's all. I'm telling you, children, everything is simple mathematics. Okay. Now one more question, children. One more question. So this is 90. This is 30. 60. So children, light ray is coming like this, children. How it is coming means like this. Light ray is coming like this, children. Now can anyone tell me the pathway, children? Like light ray pathway? Children, when it is hitting normally, how it will go? Normally it will go, children. Straight it will go till here. This is also 90. Can anyone help me? How much is this angle? Tell children, don't sit idle like that.
30.
30. Say something, don't sit idle like that. Normal, children, if this is 30, this is how much?
60.
60. So angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Children, if this is 60, this is also 60, and this is 30. Okay, children, try to understand. Children, this is 30. This is 30. Can anyone help me? How much is this angle? Can anyone help me? How much is that angle? 30, 30. This one, how much, children?
120.
Yeah, 120. Tell children 120, 120 angle. So this is denser. This is rarer, denser to rarer. Please draw a normal, children, at this point. Okay, normal at this point. You please draw normal like this. See here, children, normal if you draw. See, children, this is, see here, this is 30. Okay, 1 second. Sorry, 1 second. Yeah. Children, this is 120. I am drawing a normal, children, at this point. I am drawing normal. Okay, so children, this is also 90. If this is 90, this will be 30, children. This will be 30. Because this will be 90 and this will be 30, children. And 30 means this is denser, this is rarer. Denser to rarer, light ray moves away or not towards. This is denser, this is rarer. Denser to rarer, it goes away, children. It goes away. Like this, it goes away. Okay, so you have to imagine like that, children, and you have to draw. You are not saying, children, nobody is saying. I am only telling of all the angles. I am only telling. You are not cooperating with me. Okay, at least tell now one question and ask. Please, children, you should help. Simply, I am only telling means you will not understand anything. 30, 90, 60. This is 30, this is 90, this is 60. One light ray is coming like this. One light ray is coming like this. Can anyone help me? How much is this? 90.
90,
And this is 60.
60,
And this is normal. This is how much? 30.
30,
Angle of incidence is equal to angle of reflection. This is 30. This is 60.
60,
This is 60. This is 60. This will be how much? This is 60. This is 60. This will be how much? 60. So little bit it will go like this, like this, like this. So this is also 60. Okay. So when you draw normal, children, when you draw normal, this will be 30 degrees. Okay, this will be 30 degrees. Denser to rarer. Denser to rarer, it moves away from the normal. It goes like this, children. Children, you have to help me out. Children, you are not saying it all. Children, two questions I will say from textbook. So many questions I told already. Try to please cooperate with me. Two questions more I will tell. Two questions more because you are getting little bit confusion. That's why I am saying two more questions I will say. Listen. Still, children, like this it is there. This is 60. This is 60. This is 60. One light ray is coming and hitting at 90. Trace the pathway of the light. Question. Trace the pathway of the light. Can anyone help me out? Will anyone help me out? So children, this is 90. Because it is hitting at 90, normal incidence means it will go straight like that only, children. Because it is normal incidence. 90 means it will not refract directly, it will go. Even though how many medium it changes. This is also 90. This is 90. This is 60. This will be automatically 30, children.
30,
Okay, draw normal. This will be 60, children. Okay, and if this is 60, angle of incidence also will be 60, children. Angle of incidence also will be 60. Okay, this is 60. If this is 60, this will be 30. If this is 30, this is 60. This will be how much, children? 90. So if this is 90 means you should draw straight, children. Okay, if this is 60, this is 30, this should be 90. So it is going straight like this. Last question for the day, children. Children, you are not at all cooperating with me, children. You should say whether wrong or right. You should say, I will help you out. But you are just sitting like that means I will not feel interest to say. If people are not able to understand, I will not get any interest in saying it. Okay, this is light ray, children. So this is coming like this, children. What happens is because it is hitting at 90 degrees, it will go directly and it will hit here. Okay. After hitting here, children, what happens? After hitting here, see, children, this is 90. So this will be also 90. Okay. So both are isosceles right angle triangles. This is 45. This is 45. This is 45. This is 45. This is 90. Okay. So children, this is 45. This is 90. This is 45. This is 45 means this is also 45.
45.
Okay. So it will go like this, children. It will go like this. Why means this is 45, again this is 45. This is normal incidence. For normal incidence, it will go like this. Again normal incidence. Normal incidence means it will go straight. Then this is 90, this is 45. And here if you draw normal, this is 45.
45.
And angle of incidence is equal to angle of reflection. This is 45, this is 45. This will be 90. So light ray will come from, it will like this, like this, like this. Everything is related, children. Thank you so much. I will discuss some more questions tomorrow.